Ladies and gentlemen, welcome to this screencast in which we are going to talk about the shape of the efficient frontier. For that purpose, we have borrowed some data from the textbook on investments by Alexander Sharp and Bailey, and the data is about two assets, asset A and asset B. Their risk return profile is given to us here. We have various choices. We can choose to invest our entire money in asset A and be willing to earn a 5% return along with a risk of 20%, or we can choose to invest the entire set of money in asset B and be willing to accept a return of 15% along with a risk of 40%. The other choice, and probably a wiser choice, would be to hold both these assets in various portfolio combinations, and as I scroll down, I'm going to show those portfolio combinations to you in these two columns here. XA and XB stand for the weights that we put on both these assets, and we are oscillating between two extremes. This is the first one where you choose to invest your entire money in asset A alone. That is why we have a 1 here in this cell, indicating to us that 100% money goes to asset A and 0% money goes to asset B. Therefore, what we are going to fetch is a 5% rate of return along with a risk of 20%. The other extreme is to invest your 100% money in asset B. That's why we write a 1 here. The portfolio weight for asset B is 1 here, indicating that the entire money is going to asset B and nothing is invested in asset A. Thereby, what we get is the return offered to us by asset B alone, that is 15%, and with it comes the risk of 40%. Between these two extremes, my friends, lie various weighting combinations. For example, in the second combination, 83% of your money goes to asset A and 17% goes to asset B, and so on. We have different combinations for which the return has been calculated and supplied to us here in this column, and also the risk estimates have been given to us under two assumptions. Assumption 1 is the standard deviation, which measures the risk, has been calculated when the correlation coefficient between asset A and asset B has been assumed to be -1, that is, they are perfectly negatively correlated. In this column now, standard deviation or portfolio risk has been calculated by assuming that the correlation between asset A and asset B is perfectly positive or +1. So various risk estimates are here and here in this column as well, depending on these two assumptions. What you are going to observe is that in this column, it is possible to reduce your risk to 0. That is, you can totally eliminate the risk of your portfolio, provided you are able to satisfy two conditions, one of which is pretty obvious here, that the correlation coefficient between A and B should be -1. So that is what we have here. This Greek letter rho measures the correlation coefficient between the two assets, and when it is -1, it is possible to totally eliminate your risk. The second condition that we need to satisfy to completely reduce our risk to 0 is to select our weights carefully. What we need to do is that the amount of money that should go to the first asset, this x1 here represents the money that should go to the first asset, and the first asset in our case is asset A. So the amount of money that should go to asset A should be equal to this fraction, where in the numerator we write the standard deviation of the second asset, which would be the standard deviation of asset B, and we divide that by the sum of both the standard deviations, and we have done that in this cell here. If I show you the formula, look here in the formula bar, we have written in the numerator 40, which is the standard deviation of asset B, and in the denominator we have written 60, which is the sum of both the standard deviations. Both the standard deviations, 20 plus 40 gives us 60, and that is what we have in the denominator here. And once we do that, what we find here is that the answer is 0.66667, or simply 0.67, indicating to us that 67% of the money when invested in asset A, and obviously the remaining 33% is invested in asset B, along with when the correlation between them is -1, when these two conditions are met with, it is possible to reduce the risk to 0 or totally get rid of it. Now let us look at the shape of the efficient frontier, for which we need to plot a graph. So what I'm going to do is I'm going to go to this insert tab, and from there I'm going to pick up this scatter plot and select this chart type. I get a graphing space like this. Inside the graphing space I'm going to right click and I'm going to select my data. So let us look at our data here and see what we need to plot where. I'm going to say add series. I want to measure my risk on the x-axis, so I select this field and I pick up the standard deviation here when the correlation coefficient between the securities is 1, and for y values on the y-axis I want to measure my return, so I select this return series here and say OK, and then say OK again, so that then this information is plotted on this graphing space here. I also need to accommodate the risk when the correlation coefficient is -1, so I need to build in this series also on the graph. So let me again right click on the graphing space, select data and add another series. The X series is going to be again my risk here, but this time I'm choosing the risk assuming the correlation coefficient is -1, and then for Y values what I'm measuring on the y-axis is my return, so I select the return series from here and then say OK and then say OK again, and I'm going to get a diagram like this. So what this diagram tells us that between these lines and on these lines lie our various efficient combinations of these two securities A and B. This blue line, my friends, is known as the upper bound and is the line which represents the risk return combinations, assuming that the correlation coefficient between the two securities is +1 or perfectly positive correlation. And the red line here, which starts from here, touches the vertical axis here and then goes on to meet this line here at this point, is known as the lower bound, and this is the line that represents the efficient combinations of assets A and B, assuming that the correlation between them is perfectly negative or -1. In reality, however, you are going to agree that it is very improbable that we are going to locate two assets, the correlation amongst them would be either perfectly positive or perfectly negative. In reality, what is going to happen is that the correlation coefficient between the two assets is going to oscillate between the two extremes of +1 and -1, and so the shape of our efficient frontier is going to change. If the correlation coefficient was perfectly positive, then this blue line would have been our efficient frontier, and if the correlation coefficient was perfectly negative, then this red line would have been the efficient frontier. Since that is not probable, let us examine a possibility when where the correlation coefficient is neither +1 nor -1, rather it is somewhere between these two extremes. Let us take a case where the correlation coefficient between them is 0, and then this is going to be our risk estimate for various portfolio combinations along with our return data. Let us now plot this data to see how our efficient frontier changes. So I'm going to select the scatter plot again, select this chart type, and let me drag it here to give myself some space here, and then inside right click, select data, and then let us add our series. On the x-axis, just like before, I want to measure my risk, so I select this series here, and on the y-axis I want to measure my return, so I select this series here, and what I find is that the shape of the efficient frontier changes. Rather than a straight line like this or a kinked line like this, what we have is a line which has moved and become a little concave. So if the correlation coefficient drops from +1 and starts moving towards 0 and then onwards towards the negative area, this line here doesn't remain straight, rather it starts moving towards the left and starts getting more and more concave. So that is what you see here. The shape of the efficient frontier in reality, when we have a situation where the correlation coefficient is neither exactly +1 or nor exactly -1, the shape of the efficient frontier would be concave like this. The more negative the correlation coefficient gets, the more this line is going to move towards the left and become more and more concave. And just in case the correlation coefficient was -1 or perfectly negative, this line would become like this and hit the vertical axis here, and then go on and move this and meet this point at this place. So the lesson that we learn here is that the shape of the efficient frontier in reality is concave. Thank you very much, my friends. Bye bye.